position, which I'm going to upload it in the video, and the force position and secant method and modified secant method will be on video. Okay. Oops, wait. So I'm going to move on to the next topic, which is open the file. Sekejap ni, file tu tengah loading. Lambat. Sudah. Hello? Ya. Ya. Okay. Jadi termasuk dalam, including in chapter 6 is called the Brand's method, which is not part of the scope. Okay. You can see the title there. It's called the Brand's method, but it is not part of the topic for this course. Okay. So you can ignore the topic on Brand's method, and then let me see. Okay. Nampak kat screen open method sekarang. Dia macam dia banyak sangat buka serentak. Okay, branch method which is not part of the scope 6.4 ni. Okay. So you can ignore this topic, branch method. Then okay, multiple roots. Multiple roots means you have more than one root. Okay. So for multiple roots, we apply the Newton-Raphson as well, but the equation is slightly modified. So the modified equation for Newton-Raphson is given as follows. Multiple root. So multiple root correspond to a point where function is tangent to the x-axis. For example, a double root results from fx equal x minus 3, x minus 1, x minus 1 will have x is equivalent to 3 and x equivalent to 1 twice. Okay? Let's call double root lah. Okay? A triple root correspond to the case where one x value makes 3 term in equation equals to 0. For example, fx equal x minus 3 times x minus 1 times x minus 1 times x minus 1. Okay? So the root is x equivalent to 3 and x equivalent to 1 3 times. Okay? So that's called triple root. Okay? Multiple root pose some difficulty for many numerical method. This as described in part 2. The fact that the function does not change in sign. Okay, can so this is the equation for Newton-Raphson equation for multiple root. Okay. So the different from the previous Newton-Raphson is the function of f double prime. Okay. So in previous Newton-Raphson, we don't have any f double prime in the equation, only f prime, but now we have f double prime. Use example, use both standard and modified Newton-Raphson method to evaluate the multiple root of equation 611 with an initial guess of x0 equal 0. So we are going to apply a standard, the usual modified, the usual Newton-Raphson equation with a single derivative function with a modified Newton-Raphson with double prime function. Okay. Okay. As you remember, as you may remember, because you might not remember in my previous lecture on Newton-Raphson. Okay, you need to find the first derivative of the function. So the question for this example is the same as we used before, which is fx is equivalent to fx is equivalent to what was the function where the prime become 3x squared minus 10x plus 7. Equation 611. Okay, the function is x cubed minus 5x squared plus 7x minus 3. That was the function. It's given here. Here, fx is under the topic of multiple roots. Okay, this one after factoring is done. After doing the factorization, this is the equation. But if we expand it, we got this fx equal x cubed minus 5x squared plus 7x minus 3. Yeah? So first derivative yields 3x squared minus 7x plus 7. Okay. So if we substitute inside this equation, then the standard Newton-Raphson equation previously mentioned in my lecture, which is, if you could still remember, the standard equation is xi plus 1 equivalent to xi minus fxi divided by f prime xi. Okay, so xi plus 1 equal xi minus fx. So this is the function fx before taking the derivative. This one is f prime x after taking the derivative. Okay, and once we solve this particular iteration, start from x equals 0. Initially x0 equals 0. So this is the answer. We got 0.9976551 after 6 iteration. The true error for the 6 iteration is 2.2 compared to the true value answer, which is 1.0. Okay. One point oh is one of the root. Okay. Here 1.0, and then the other root is 3.0. Okay. For the modified method, we have to take second derivative for the function. So the second derivative is f double prime equivalent to 6x minus 10. Then we use the equation for multiple root Newton-Raphson as shown previous in the upper transparency just now, which is x I plus 1 equal xi minus fx multiplied by f prime x. So this is your fx multiplied by f prime x divided by f prime x square. So f prime x square minus fx multiplied by f double prime x. Okay. So we start the iteration from x equivalents to 0, and we see the Newton-Raphson method for multiple root converges very rapidly. Okay, whereby at the third iteration we already got the root to be 1.5 times 0, 2. And the true error is 0.3324, 3.324. Okay. So the reason for it to converge during at the third iteration, because the modified formula converge 4 times quadratically, 4 times as fast as the, what do you call it, standard Newton-Raphson equation compared to the, so the modified Newton-Raphson converge 4 times faster than the standard Newton-Raphson method. Okay. So, or we can also use both methods to determine the single root at x equivalents to 3. Because I told you just now, after factorization of the function, we got here. So, other than x equal 1 to be the root, x equivalents to 3 is also the root. So, to get the root for x equivalents to 3, we apply the modified and the standard Newton-Raphson, but using the initial guess of x not equal 4. Just now we use x not equivalents to 0. Okay, and we got the answer approach to 1. To get the answer of 3, so we use initial value to be 4. So you notice the cycle, both of method can be considered to converge quickly, with the standard method turn out to be more efficient. Okay, because until 5th iteration of the standard method, we got the answer of 3.0060 there, with an error through error of 0.00607. Okay, 6 times 0, 2. Okay, whereas here we got 50 in front, or 77 followed by 77. So standard method for this particular second root of x equivalents to 3, which is a single root, okay, turn out to be at the same level as the modified method. So the modified is efficient for repeated type of root. Because x equal 1 is repeated twice, so it's efficient for multiple roots. Newton-Raphson approach. See, the x equivalents to 1 twice, so that's double root. Tend to converge faster using multiple root Newton-Raphson approach. Okay. Now look at the system of nonlinear equation now. Okay. All right. System of nonlinear equation. First method that, okay, for example, this one, x squared plus xy equals to 10, and y plus 3xy squared equals 57. So we have two equations and two unknown. There are two simultaneous nonlinear equations with unknowns x and y, and can be expressed in the form of equation 617. Here, this is the form 617, as xu equal x squared plus xy minus 10 equals 0. That means we bring this 10 to the left hand side. The v equal y plus 3xy squared minus 57. We bring the 57 to the left hand side. Set it equivalence to 0. Okay. So that is the u and v. Okay. So the first method that we are going to use is called fixed point iteration. Okay. The fixed point iteration approach can be modified to solve two simultaneous nonlinear equations. This approach is illustrated in the following example. Use fixed point iteration to find the roots of equation 619. This one, 619, which is A and 619B. Okay, we're going to use this fixed point iteration. Note that a correct pair of root, that means the exact answer is x equals to 3 and y equals, x equals to 2 and y equals to 3. Exact answer. Initiate the computation with initial guess of x equal 1.5 and y equals 3.5. Okay. So we can, so the approach is actually similar approach to the fixed point iteration that we done before for single non-simultaneous equation. For single non-linear equation that being covered earlier, the approach is the same. So what we can do, looking at this 619a equation, we can write x equivalent to 10 minus x square, or in other words, xi plus 1. Before we put the subscript I plus 1 and also subscript I, we write the x in terms of, express the x, this x, in terms of the rest that we brought it, that we need to bring it to the right. It doesn't matter that you can see both equation has x, both side of the equation got x, it's okay. Okay. So for fixed point iteration method, we just try to write x equal the rest, put it on the right hand side. Okay. But writing this x equal equation, this is not the only equation we can write, correct? We can also write x equal this x, bring minus 10, we got positive 10, and then xy become positive, become 10 minus xy, and then the square root, the square we just put it as plus minus, so x is equivalent to square plus minus square root of 10 minus xy, also can, no problem. Okay. And then the b equation, we write it as y equal now. So for this particular example, yes, y equal my 57, positive 57 minus 3xy squared. That means we keep y on the left hand side, but we bring the positive 3xy minus 57 to the right hand side. Become positive 57 minus 3xy squared. Okay. Here. And then we include the subscript. For the left hand side, we put the subscript I plus 1. And the right hand side, we put the subscript I only. Okay. I plus 1, I plus 1 then. Okay. For the left hand side. Note that we drop the subscript for the remainder of the example. That means the subscript do not need to be there when we do the computation. On the basis of the initial guess, equation 611(1) can be used to find the new value of x. So this is the initial x and y value to start with. Okay, so we just choose a value that is just so happen here they choose with decimal places, but it doesn't have to. You can start with x equal 1.0, y equals 3.0. Don't have to have a decimal 0.5 there. Okay, so if we maintain with this initial value of x 1.5 and y equals 3.5, then we can write x is equivalent to 10 minus, use this equation, okay? So 10 minus 1.5 square divided by 3.5. So we have 2.21429. And the result and the initial value of y equal 3.5. So we substitute here now. So you got 57 minus 3. And the x value, you use the latest one we got from the calculation. Okay. Don't use this, the old number. Otherwise, the convergence will be slow. So we keep update the value to the latest one that we calculated. Okay. So 3 times 2.21429 multiplied by 3.5 square, which is the initial value for y. We got negative 24.37516. Thus, the approach looks like it's going to be converged, all right? Because it's already given that the correct answer is y equals to 3. And we start by assuming y equals 3.5. By right, we should get, after iteration number 1, we should get like 3.2 or something like that. I mean, from 3.5, the answer looks like supposed to be looking like approaching to 3. Instead of that, we got negative 24.3756. So it seems that the answer for y is diverging. This diverging behavior is more pronounced, which is more evident, more clearer on the second iteration. Okay. So on the second iteration, we got x equal negative 0.20, whereas the root is 2. Okay. So from 1.5, jump to 2.21, bypass the 2.0, and then it jumps to negative 0.20910. Obviously, the approach is getting worse, deteriorating, because the y actually go to 429.709 positive. So it's not a good. It's not only not good, but it is terrible way of calculation, performing the calculation, terribly wrong. So we can repeat the computation, but with the original equation being set up in a different format, like that. So we write x equal, as I told you, writing the equation is not the only way that been shown before. That means the x equal, this is not the only equation possible to write this and this. Having the solution to be converged, to be diverse, so we change the format of writing the equation as x equal positive square root of 10 minus xy, and y equal positive 57 minus y over 3 over x. Just now I said we can write it x equal plus minus, correct? Plus minus square root of 10 minus xy. Okay? So x can be positive or negative. But here they maintain only the positive square root because it is already known that the answer is the correct answer. I mean the exact answer is positive 2 and positive 3. So might as well do not include the negative value in the in writing the equation because if you put the negative value, then it doesn't have any value to, it doesn't have any number to compare with. So the given value, the only given value are positive in terms of the sense of the number. So just focus on the negative part, not the focus on the positive answer, and neglect the negative one. So after writing it in this form, we substitute the trial value of 1.5 and 3.5, and the x turned out to be equals 2.17945, whereas y equal 3.0495. So this time the answer seems to be more promising. So more promising because it is approaching to the true value of x is equivalent to 2 and y equivalent to 3. So y is 2 point something, x equals 2 point something, y equals 3 point something. Okay. We can also check the condition whether the equation will converge or not by testing on these two criteria, which is a sufficient condition for convergence. Okay, I mean if it is fulfill these two requirements, then the equation will converge. Okay, so this is a partial derivative of u with respect to x and partial derivative of v with respect to y. Okay, so you can use, you know how to take partial derivative. You check with this equation, and then if both fulfill the requirements of less than 1, then that is all the sufficient condition being fulfilled for the function to converge. Okay, the next method that I'm going to show you on this multiple root is called Newton-Raphson. Okay, just now we have open method, right? A fixed point iteration. Now we have Newton-Raphson. So the Newton-Raphson for nonlinear system is computed by using these two formula. Okay. So x, the updated value of xi plus 1 equal the previous value of x minus ui multiplied by partial of v with respect to y minus v partial of u with respect to y, divide by du dx times dv dy minus du dy times dv dx. Whereas for the y variable, y plus I equal yi minus v du dx minus u dv dx divided by du dx times dv dy minus du dy times dv dx. So notice the denominator is the same. Only the difference is on the numerator. So we have v du dx minus u dv dx, whereas here we have u dv dy minus v dv dy. Okay, let's look at an example. Use multiple equation, Newton-Raphson method to find the root of 619. Noted that a correct pair of root is 2 and x equals to 2 and y equals to 3. Initiate the computation with initial guess of x equal 1.5 and y equal 3.5. Okay? Okay, first of all, compute the partial derivative and evaluate them at the initial guesses of x and y. That means delta u naught over delta x equal, take the partial. I'm sure you know how to take partial derivative. Okay? If you don't know how to take partial derivative, it's just like a normal differentiation by treating the unrelated variable to be constant. Okay? So delta u over delta x. Here. Delta u over delta x will be 2x plus y minus 0. Okay? 2x plus y minus 0. Du delta u over delta x, delta u, just now delta u over delta x. Right? Okay, now delta u over delta y will be x squared becomes 0 plus xy will be x, 10 will be minus 10 will be 0. Next, delta v over delta x, this one will be 0. So we got 3y squared, the answer, right? Minus 0. And then delta v over delta y, this one will be 1 plus 6xy minus 0. Understand, how to take partial derivative. So this is the calculation for the partial. Okay. The subscript naught refers to the equation resulting from the partial derivative with the initial value substitute inside it. That means after you take the partial derivative, you substitute the initial starting value of the iteration. That's why u not refers to. Not means initial value. So you substitute initial value after taking the derivative and you get a single number, 6.5, 1.5, 36.75, 32.5. Okay? Then you substitute here. Okay? Same as here. This parameter at the denominator is called what? Jacobian. Thus, the determinant of the Jacobian for the first iteration is 6.5 times 32.5 minus 1.5 times 36.75. Okay. Towards the end of the previous chapter, we can find that the formula to substitute. Okay. The 6.5 times 32.5 times this one minus 1.5 times 36.75. Okay. this denominator part, Jacobian, we call it. Jacobian of the Jacobian for the first iteration. The value of the function can be evaluated at the initial guess of as u0 equal, okay, 1.5. Okay, this one u0 equals ni substitute inside here. u0 is equivalent to here, okay, u0 dv over dy minus v0 du d0 over dy. Okay, so for x1, that means when I equals 0, the initial iteration, x, when I equals 0, that means x subscript 1 equal x0 minus u0 dv0 over dy minus v0 du0 over dy divided by du0 over dx dv0 over dy minus du0 over delta y delta v0 over delta x. Okay, so the calculation being done here is taking it, we call it the numerator part, the denominator part being calculated separately. Okay, so this negative 2.5 goes here. Okay, and then this 32.5 is from here, and then one negative minus is minus as appeared in the equation. 1.625 is from here, v0 minus 1.5, which is here, du0 over dy. Okay, what else? Okay, and then divide by the Jacobian, whatever they call it, Jacobian for the first iteration, which is 156.125 down here, as well as for y. So you can see in the equation, same here. See? Jacobian they call it. Actually the determinant, right? Determinant of a 2 by 2 matrix, right? It's called the Jacobian of the system. Denominator of each of the two equations is formally referred to as the determinant of the Jacobian of the system. Okay, this is the Jacobian as calculated from here. Okay, the results are converging. Okay, see that initially we use the number x0 equal 1.5, y 3.5. After first iteration, we got x equivalent to 2.03 and y is 2.84, closer to the actual answer. So we can see that the computation is converging. The computation can be repeated until an acceptable accuracy is obtained. Okay, understand? All right, so okay, the tutorial I will this one is different from the one that I'm going to assign later. Okay, all right, let's look at what is going to be the next topic. Okay, so it takes a while for the load file to load. Chapter 6, chapter 7 now, which is on polynomial. Okay. Roots of polynomial. Okay. Hello. Ya, ya. Ada. Oh, mana? Tak ada. Oh, kenapa dia naik lah? Bukannya oh, yang nama yang you bagi tu. What? Nanti I call you back. I call you. Punya file ni. Okay, roots of polynomial. I'm going to explain what is polynomial first. Okay. Alright. Polynomial n is equivalent to a0 plus a1x plus a2x square plus dot 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 plus an xn. So that is called polynomial. Understand? So n is the order of the polynomial. That means the power is 10, so we have 10 order of polynomial. The a is called the constant. Okay? Constant coefficient, the a. Although the coefficient can be complex number, but as far as the material in this, only real numbers of the coefficient will be used. Don't use a complex number. For example, a can be 2i, 10i. I is square root of -1. But we are not going to get involved in complex number for the coefficient. We only limit for the coefficient of real numbers. But the root can be real and complex, or it can be real or complex. The root is allowed to be complex. For example, if you solve, if you got if let's say you got a quadratic polynomial, right? Quadratic equation where the b square minus 4ac. Okay, before that, how do you write the root of quadratic equation? What is the exact answer for the square root of b square minus 4ac? What is the exact answer for the polynomial root? What is the formula? Anybody remember? X equal minus b, right? Minus b plus minus square root of b square minus 4ac divided by 2a, correct? So the square root of b square minus 4ac, it turn out to be negative, then we can get a complex root. Okay, so for n order polynomial, n order, that means polynomial of n order equation or polynomial, for example quadratic, cubic, n equals to 3 for cubic, right? There are n real or complex roots. Okay, it should be noted that these roots will not necessarily be distinct. That means the roots can be distinct, means different from each other. Okay, so it not necessarily be different from each other. Can be repeated root. Repeated means the root is the same. If n is odd, then there is at least one real root. Okay. If complex root exists, they exist in conjugate pair. That means it's the lambda plus mu I and lambda minus mu I, where I is square root of minus 1. Okay. Okay, so those are the root of equation. But if you have n root order of polynomial, there will be 100% sure that you have n number of roots as well. That means if you have quadratic equation, you must have you must have 2 roots. The roots can be repeated, it can be distinct, or it can be complex. Okay, this one you should learn in what course? Algebra. It's not really calculus. It's just algebra course. Okay, these are the description of polynomial, deflation. Okay. So the first method that we are going to apply to solve polynomial is called Mueller method. Okay. Okay. In Mueller method, what we do is first let's say we have a polynomial. We have to assume the root to be parabolic. Parabolic means second order polynomial. F2 equal ax minus x2 square plus b times x minus x2 plus c. Okay, so we assume the root to portray a polynomial behavior like that, parabola type of polynomial. Okay, this Mueller parabolic equation assumption is better than the second method, where second method only assume a linear straight line convergent. Whereas if you use Mueller method, see the assume black curve, the bold black curve tends to portray the pattern of the light black curve that represent the actual function. Okay, so the actual function is given as a black but a lighter curve, whereas the black solid curve here is the simulation done by assuming parabolic root, not parabolic, parabolic curve of Mueller method. Okay, so the root estimate is closer to the actual root, where compared to the secant method, the root estimate is shown further apart most of the time like that. Okay, not all lah, but say 99% or 98, 95% of the time. Okay, in Mueller methods, what you need to assume is first the H naught, which is the step size, the different in computing the coefficient A and B. First, we need to have 3 initial points for the start. Okay, because in parabola we have to have 3 points, 1, 2, 3, so that we can write we can represent a parabolic curve. Whereas in secant method, we only need 2 points initially to represent the straight line. So after getting the 3 points as an initial value, we calculate the HO, the difference in terms of the H1, X1 minus X0, X1 minus, so this difference is H1, this difference is H2, you know, H0, sorry, H0 is this difference, H1 is, okay. So then you calculate your delta naught, the increment value for the function with respect to the initial point. So delta 1, delta 1, delta 0, delta 1. And then substitute in the parabolic assume function we got here, this one. And subsequently we solve for AB from these two simultaneous equation, and also the constant C as well, ABC. Okay. So to find the root, we apply the quadratic formula by substitute the value of A, B, C inside this equation to get the next trial value. Okay. So by using this quadratic formula, we are able to find the complex root together with the real roots. Okay. And the relative error is calculated by using this equation, absolute value of x3 minus x2 divided by x3 times 100. Okay. So example, use Mueller method to find with guesses x0, x1, x2. See, I told you you need to find you need to use 3 initial points. To find the root of this equation, it's a cubic polynomial equation. The exact solution is this -3, -1, and 4. So we don't have any complex root for this particular polynomial. First, you calculate the function at the guess point. This is our goal, the guess point, the initial value. So these are the value F0, F1, F2. And then from there, we calculate H0, H1, delta 0, delta 1. Okay? Using this formula. Here. Okay? H0, H1, delta 0, delta 1. Okay? After doing that, you substitute the calculated value into equation 724 to 726. Here, substitute inside here to get the coefficient of ABC. Yeah, okay. And then the square root of the discriminant can be evaluated. That means you calculate this first. Square root of the determinant. And then we substitute inside the equation of, because the absolute value of 62.25 plus 31.5511 is more than 62.25 minus 31. A positive sign is employed in the denominator of equation B, 727b, and the new root can be determined by calculation of x3 here. Okay, so this one x3, the new root. Okay, so we got the new root 3.97647, and the relative error is calculated from this equation. X3 minus x2, divide by x3, take the absolute value time 100. So we got here. Because the error is large, new guesses are assigned. X0 is replaced by x1, x1 is replaced by x2, and x2 is replaced by x3. That means we throw away the initial x0, but we replace it by the x1 earlier assumed. And then x1 replace it by x2, and then x2 we replace by the newly calculated x3. So we got the three value now for the second for the next iteration, the new iteration. So we calculate the f value again, the h0, h1, delta 0, delta 1, and then a, b, c, and then get the x4 and so on. So these are the value being tabulated in the table. Okay, first we got 3 the root is 5, and then become 3.97, and then become 4.00105, and then become 4.0, 4.00 also, but with more zero in front. Okay, so that is how the Mueller method is done. Okay, to find the root of the polynomial. Okay. So after that, so you got this one, you use the long division, and you got the second order polynomial next for you to solve to get the other two roots. Okay. Okay. For today, that's the topic that I going to talk about, that I intend to talk about. The next lecture, I will talk about another method. We call it Bestow method. Bestow method. Okay. So before I close this lecture, I need to download the attendance. Okay. And don't forget, because as I told you, the code, those who those assignment that I am going to give to you based on the online problem. Need the code to be able to register and also complete the test and also the quiz. So please, I'm going to WhatsApp you my account number. Once you the code cost is 87 as I told you, then you get the soft copy of the text as well as the code. Okay, so you need to do it very fast. Otherwise, those who get it will able to do it first. Those who get it late, then you won't be able to keep up with the quiz and tutorial. Then there will be a little bit difficulty for me to accumulate all the marks later. Okay, so I need to download the attendance. Okay, now I'm able to download it. Hold on, don't what we call this get left the Teams yet. Okay, hold on. Okay, before you go, I have one little quiz for you. Okay, this quiz is for quiz number 2. It's a simple one. This is like a giveaway quiz. Okay, so you just do it like before, email it. Okay, and the quiz will take about 5 minutes only, and then you upload it 5 minutes, 10 minutes. Okay, so the quiz is supposed to help you to gain some marks, right? Because it's not difficult quiz, it's very straightforward. Okay, so this is the question. So you use Kudin631 @gmail to submit your quiz. Don't use other email. I notice some students they use other email. If you use other email, I might not be able to give you a mark for it because I don't check the other quiz submitted to other email other than the Kudin631. So before I display the question, you have anything to ask now? No, Okay, very good. So for the second question, hold on, it's still waiting to display. Okay, takes a while because of the slow.
The Bluetooth device is
Okay, tak apalah. Since I give you the chance that
Mr. Cat, soalan Mr. Cat kasih kat sini ke?
so net you tapi
sebab
slow sikit komputer ni kejap
okay.
Belum lagi, belum.
Orang pun tak nampak. Mr. Cat boleh ke bagi kat WhatsApp?
Bagi kat WhatsApp tak, saya tak bagi kat WhatsApp because kalau saya makan masa sikit nak pergi ke WhatsApp, nak transfer semua, tapi tak apa, dia pendek je soalan dia. Kejap
Sebab
pendek
saya punya screen tak keluar, line UKF slow Mr. Cat.
Okey. Kejap.
Maaf Mr. Cat menyusahkan. Terima kasih.
Kejap tak apalah, saya WhatsApp juga, tapi sementara tu siapa yang ada display tu dia. Boleh tengok lah. Okey juga. Kejap. Saya kena transfer file dulu. Okey. So boleh buat juga sekarang salin saja, tapi yang nombor 2 tu tak termasuk method yang saya lecture hari ni. Itu saya sebut dah dalam kurungan. Only for online lecture, not including other like recording pun saya belum upload lagi. So only online lecture excluding today for question number 2. Okay. So good luck, and now is exactly 4 p.m. So I expect to get you not more than give 15 minutes together for submission by email. Okay. Have a nice day. I will upload it. Mana saya punya thumb drive. See you next time. Bye.
Thank you, Mr. Cat.
Okay.
Thank you, Mr. Cat.
Welcome.
Thank you, Mr. Cat.
Lambat lagi tak?